Hello everybody and welcome back to the shop. In today's video we're going to be starting part 1 of a CNC build. Inlay up here or here. Somewhere I'll show a picture of the rendered final model. It's going to be a smaller CNC. My goal is to create more of an open source version of the Bantam CNC mill they released. I just think that $5,000 for a machine of that size is ransom, plus the fact that you're stuck using their software to do anything. So this one will obviously run on Mach 3 or Linux EC, whatever you really want it to, because it's open source and you do what you want with it. I'm going to be reusing the motor control system from my old mill, and between that and the spindle, that's about the only things I'm reusing. The rest of it's going to be brand new. So let me show you what you're going to need for this part of the project. Alright, so here's the stuff you'll need for today's project. You'll need a set of the drawings that are available on my website. I'll have a link in the description. I'll have the step files and the PDF drawings. These are in inches, so I was originally going to make this whole thing in metric, but metric metal in the United States is exceedingly expensive. So I had to scale it up to imperial for that, and I forgot to change that back to metric. I will notate while we're doing this what those numbers need to be. Alright, I'm going to need a deburring tool, because the metal from the metal shop will be quite burred. So for me, I'm using aluminum for this build. You can use steel, and the reason I'm using aluminum is, well, it was easier to get it. And sorry about the furnace. It's pretty cold out right now. So what I'm going to be using are Forstner bits, because I can cut through aluminum with these. So this will cut through the aluminum at the correct diameter. If you're going to do this in steel, hold on one second, gotta grab one. You're going to want one of these. These are a core auger. They work pretty good when you can get them out of the box. But you can get these on Amazon. They're carbide teeth. It's basically a hole saw, but they're metric, and these are what you use for cutting out steel. So we're not going to be using these today because I'm not cutting it in steel. The next thing you're going to need are some taps. In today's build, we're going to need some M4s and M5 taps. I'm going to try out these Volcal taps today. They supposedly don't break off in your drill, so I'm going to try that. If that doesn't work, well, I'll get to explore tap removal in aluminum today, which will be fun. And then if those don't work, I got traditional style taps. I didn't take both sets out. And then these are the 4mm that are needed for the set screws, which I don't have in this picture, but I have to update the drawing some. I did some changes. I added some 4mm grub screws to hold the 30mm rails to tension so they can't slide if the fit's not quite perfect, which using a Chinese Forstner is possible. I'm not going to be boring anything because I don't have a boring head. And we're also not doing the shelf for the front one to hold the bearing in place. I am just going to green Loctite it into place. So if you're not doing this on a mill, get some green Loctite to hold the front bearing in place. Let's see here, anything else that, and as you can see with that, I didn't remove these, and I gotta change these drawings a little bit. These are definitely work in process, so I gotta re-upload the files, but they'll be updated when you guys see it. Let's see, what else will you need? You need a burring tool to deburr the metal. I can't remember if I said that. You're going to need the corresponding drills. So I think it's like 3.5 and a 4mm drill for the holes we got to tap. Get that out of the way. You need 2 pieces of 30mm linear rod. I'll have links to all this stuff in the project page. A 16mm ball screw with ball nut. They also come with the mount and the 2 fixed block and floating block. We're not going to actually use these. We're going to use some of the parts out of them though. And I might need to 3D print a boss to hold the seal in place snug with the back plate. We'll get to that when we get to it though. You're going to need 30mm bearing blocks. And then these also come with it. So you're also going to need a snap ring tool, which I forgot to pull out. And then this just clamps onto the fixed end and has a set screw to lock it in place. Once you get this where you want it, I would recommend you, where's that at? There's a set screw in here, right there. I would recommend taking that out, put some green Loctite on it, and then set it so it doesn't move. You're going to need a square. You're going to need a caliper. You're going to need some layout fluid. And you're going to need a scrub, which I don't have in here. It's on my coverall. So that's about all you're going to need for today. So let's get to it. Okay guys, I called an audible on this, so I remembered I had to make the front one smaller because the rear's a 28 and the front's a 26 millimeter bearing. Glad I measured that. So what I did is I went down the depth of this Forstner bit, which happened to be the same depth as the bearing, and then I came back, and let me get this back in the box, and I used this 18 millimeter boring bit to finish the hole for the clearance hole for the actual lead screw. So it's a little dirty right now, so I don't really want to put this in all the way, but this will fit flush on the outside so that the C-clip will actually hold it tight and you don't have to worry about as tight of a fit with your measurements. I mean, as it is, this is slightly loose because, well, Forstner bits aren't a precision tool, and I don't have a means to make a precision 26 millimeter hole. So that little shelf is there. Whoops. Drill chuck. And then you just bore through the rest of the way with 18 millimeter, and you're good to go. I also discovered that these actually do work pretty good on my drill press, so I'm just gonna make the 30 millimeter holes with this instead of the wherever that one went, 30 millimeter Forstner. It goes a lot faster, there's a lot less mess, and I think the holes are actually more accurate. So I'm not going to bore you with making those holes. I mean, it's literally just drilling a hole. I will do a starting hole though with this 9/64 bit, just so that the larger bit in here, the pilot bit that this holds, doesn't wander. That's just good practice. And then I will bring you back when I lay out the end pieces for the 5 millimeter. So, be back in a few. Okay, so I've finished the parts for this. As a tip for you, if you're gonna do this project, where did that go? Just use these, don't bother with the Forstners, it works a lot faster. Just one second. I did use the Forstner for this step here though. I can't remember if I told you that already. But especially for the 30 millimeter, even for the smallers, use this style because all you do is you go halfway down on one side, halfway the other side. It makes a lot better surface finish. That also will make it so it doesn't wallow out, so the part's tighter. I had a little bit of an issue on this one where it's a little looser because it wallowed out, so I'm going to have to, what's it called, do a little shimming, make it nice and square. But on this side they fit really nice. So what I did is I just finished drilling the holes. Now I'm going to tap them. I'm going to try this new tap, see how it goes, and put it on camera in case it failed miserably. I drilled it to, I think it's 3 or 3.5 millimeter. I can't remember what it is at this point. Yeah, 3 millimeter drill for a 4 millimeter tap. So, to give us all the chance in the world, I'm going to use a little tap magic here. Just to, hopefully we don't break off this tap. So I'm just going to go down and you know this actually works. I'll be dang. Of course, now that I said it, I'm going to jinx myself and break it off on the last hole, aren't I? Because of course I would. I'm also not going to be able to finish the tapping I have to do on this today because my 5mm tap is broken. So what I'm going to have to do is wait for a new one from McMaster Car to arrive to finalize those taps. But I can start the hole here, and I can start the ones on this end with the 5mm one of these I bought. This should get me started at least, and then I'll finish it on the when I get the new tap in. It won't be a big issue. Alright, so now we see if it fits. Just gonna reuse the old screws. There we go. Now it's attached. Now I just need to put this in the arbor press and press this all out so I can stack them on the inside. So now that I have the parts done, I'm gonna give my conclusions for this part. First, these Volcal taps work really good. There we go, so you can see it. Didn't break it. Recommend them. You can get them on McMaster Car. I think I put a link to these in the build list. I can't remember. Either way, they work. You will need to get longer ones for this part right here, because this has to go down like 30mm, and those are only like 1 inch long. But this is the part. I made these when someone called me, so I didn't get that on camera. But I have to finish tapping these 2 holes right here to go all the way down. They're only going about 1 inch down right now, and they still got another 1 inch to go. And let's see here. bearings fit in nicely. I have to make a bushing for the grommet because I didn't think that far ahead when I was making this. I should have left the lip there like I did for the other one. Not a big deal, I'll just make one on my 3D printer. It'll take probably 10-15 minutes. And that's really about it for these parts. The only difference between the front and the back is adding this bracket on the front one. You add the shelf for the smaller bearing, it just sits right there, flush. And then the ball screw, wherever that went, that slides right through. And I'm not going to press it in now because it's a tight fit. But it'll stick out just enough to stick the snap ring on, and then that doesn't move anywhere. So that's about it for this video. I will have the drawings and the models in the description on the website. This project's probably going to take a little longer because I have to wait for materials and a budget, so I can't spend a lot of money per month because the wife gets mad if I do. So this will probably be a monthly project, so probably beginning of next month I will have the next video up for this series. So yeah, all I got to do now is finish tapping those and then paint it. I'm going to be painting it machine gray because that is the custom of things being gray. So yeah, if you have any questions, message me in the comments, or yeah, I think I have my email address in there if you have questions too. But other than that, hope you have a good day and see you next time.